Hey calculus, let's practice the chain rule. Number 1, we are taking the cosine of 3x. So we are cosigning 3x, which means our outer function is cosine and our inner function is 3x. So the first step to take the derivative of the outside cosine is negative sine. That's the derivative of the outer. We plug in the inner as is right inside there, so that is where our 3x goes. So that's the inner as is. And finally, we multiply everything by the derivative of the inner. The derivative of 3x using the power rule is 3. So that is the derivative of the inner. So our final best full credit answer, that coefficient 3 goes in front. So we write it like this: negative 3 sine of 3x. All right, let's look at number 2. Now we're taking the cosine of x cubed. So we're cosigning x cubed. We're doing this to this. So our outer function is cosine. Our inner function is x to the third. So we take the derivative by using the chain rule. The first step, again, the derivative of the cosine, the outer function is negative sine. So we always put in a blank set of parentheses. That is the derivative of the outer. The second step, we plug in the inner as is. So that is where we put x cubed. That is the inner as is. And finally, we multiply everything by the derivative of the inner. The derivative of x cubed using the power rule is 3x squared. So that is the derivative of the inner. Now to simplify that, f prime of x, we want to put the 3 in front. So I'm just going to put this entire term in front. So we have still negative 3x squared times the sine of x cubed. Final best full credit answer. Number 3, now we have the cosine of x all cubed. We are cubing the cosine of x. So our outer function is something to the third. Remember, the outside function is always doing something to the inside function. All right, so the outer is something to the third, and the inner is cosine of x. All right, so we get started. The first step of the chain rule, the derivative of the outer, the derivative of something to the third using the power rule is 3 times something to the second. That is our derivative of the outer. Remember, you always put in a blank set of parentheses. You never put in an x when you take the derivative of the outer. Second step, we plug the inner as is right inside that blank set of parentheses. So the cosine of x goes here. That is our inner function as is. Third step of the chain rule, we multiply everything by the derivative of the inside. The derivative of cosine, of course, is negative sine of x. Make sure you put it in parentheses so it doesn't look like subtraction here. So that is our derivative of the inner. To simplify it, the 3 times the negative 1 is out front. So our final best full credit answer is negative 3 out front. It doesn't matter the order of these two things. You can put the sine there and then the cosine of x all squared, or you could reverse these. It doesn't matter. But that 3, the coefficient, must go out front. Number 4. Remember when you see this weird trig notation, that exponent right here, 2, that applies to everything immediately to the left and to the right. So rewrite it, because it's easier to see what's outer and inner. That is the same as the sine of x all to the 6th. Now that you can see that this is your outer function, you're sixthing the sine of x. So our outer function is something to the 6th, and our inner function is the sine of x. Okay, the chain rule, the derivative of the outer, that is going to be a power rule. The derivative of something to the 6th is 6 times something to the 5th. That is the derivative of the outer. The inner as is goes right inside there, sine of x. All right, so that is the inner as is, Now finally we multiply everything by the derivative of the inner. The derivative of the sine is the cosine of x. So that is our derivative of the inner function. All right, really, there's nothing to simplify there. All right, you just are kind of done. 6 sine of x all to the 5th times the cosine of x. Number 5, we have negative 6 times the sine of 3x. We're taking the sine of 3x. So that negative 6 comes along for the ride. I always make it part of the outer function so we don't forget about it. But the outer function is sine and the inner function is 3x. All right, so the 6 comes along, the negative 6 comes along for the ride. The derivative of the outer, the derivative of sine is cosine, blank set of parentheses. So that whole thing is the derivative of the outer. We plug the inner as is right inside there. So 3x, that is the second step. That is the inner function as is. The third step, we multiply everything by the derivative of 3x using the power rule. The derivative of 3x is 3. So that is our derivative of the inner function. All right, to simplify this, we combine the negative 6 times the 3, and we put the negative 18 out front. So we have negative 18 cosine of 3x. That's as far as you need to go. Number 6, we have 5x plus 3 all to the 7th. We are seventhing 5x plus 3. This is my outer function. So my outer function is something to the 7th, and my inner function, it even looks like it's inside 5x plus 3. Okay, so we get started. The derivative of the outer, the derivative of something to the 7th using the power rule is 7 times something to the 6th. That is my first step, the derivative of the outside function. Second step, we plug the inner as is right inside there. So inside there is 5x plus 3. That is my inner as is. And finally, we multiply everything by the derivative of the inner. This is power rules. The derivative of 5x is 5, and the derivative of 3 is just 0. So 5 plus 0 gives me 5. That is my derivative of the inner function. So now when we simplify this guy, we just multiply the coefficients, the 7 times the 5, and we get 35 out front times 5x plus 3 to the 6th. There you go. Number 7, we have 4x to the 3rd minus 7 all to the negative 6. We are doing the negative 6 to that whole thing. That is my outer function. So I write that something to the negative 6th. My inner function is that cubic, 4x to the 3rd minus 7. This is just one cubic function. So 2 functions, 1 chain. All right, the derivative of the outer, this is going to be a power rule. The derivative of something to the negative 6th is negative 6 times something to the negative 7. Be careful. Negative 6 minus 1 is negative 7. So that is the derivative of the outer. Second step, we plug the inner as is right in there. So that inside would be 4x to the 3rd minus 7. That is my inner as is. Second step of the chain rule. Third step, we multiply everything by the derivative of the inner, and this is power rules. The derivative of 4x to the 3rd is 12x squared. The derivative of negative 7 is just 0. So this right here is the derivative of the inner. We have all 3 steps. To simplify this, again, you just multiply the numbers together. Negative 6 times 12. That would be negative 72x squared, and then we have 4x to the 3rd minus 7 all to the negative 7th. All right, we could get rid of the negative exponent, and we could have negative 72x squared on top, and we could move this whole gig down to the bottom, and then that exponent would become positive. So don't forget about how to simplify negative exponents. So those are 2 ways to write the correct derivative. Okay, number 8, we see that weird trig notation again. So remember that 4 applies to everything immediately to the left and to the right of it. So rewrite it. All right, all to the fourth. So we have the cosine of 7x all to the fourth. Now look, we have three functions, you guys. We have the cosine, we have 7x, and we have something to the fourth. So the number of chains is always one less than the number of functions. So if we have three functions, that means we have two chains. This is a double chain. So you get started, as always, what is the outermost of our three functions? What is the outermost? What function is doing something to the other two? Right here, something to the fourth. We are fourthing all of this. So our outermost function is something to the fourth. Now the inner as is everything else. So that is the cosine of 7x. Now here's another way to recognize that it's a double chain. This is still a composite function. You still have an outer and an inner. That tells you that there's another chain. So now we keep going. Right here, what is the outer function there? Well, the outer function is cosine. So our second chain, the outer function is cosine, and the inner function is 7x. And now we know that we're done because this is no longer a composite function. So again, two ways to figure out if it's a double chain. Count your functions. 1, 2, 3. 3 functions, 2 chains. The number of chains is always one less than the number of functions. You can also catch it right here. So when we do a double chain, on the first chain, we only do the first 2 steps. Only the first 2 steps. All right, so let's get started. The derivative in our first chain, the derivative of the outer, the derivative of something to the fourth, is 4 times something to the third. That's the derivative of the outer. All right, now we go to the second step. We plug in the inner as is, that whole thing right there. So we put in the cosine of 7x. That is the inner as is. All right, and that is all we do on the first chain. This is the first chain. On the first chain, you only do the first 2 steps. Derivative of the outer, plug in the inner as is. Now we start over and we go to the second chain. And the second chain, we do all 3 steps. Okay, so we're starting over. The derivative of the outer, the derivative of cosine, is negative sine, and we need a blank set of parentheses. All right, so this right here is the derivative of the outer. Second step, we plug the inner as is right in there. So 7x gets plugged in right there. So that is the inner as is. And then finally, on the last chain, you do the last step. What's the derivative of the inner here? The derivative of 7x is just 7. So that is my derivative of the inner. And this right here is the second chain, all 3 steps. Okay? So this whole thing right here is the derivative of this inner function, which is why you have to start over. So again, when there's a double chain, the first chain, you only do the first 2 steps. The derivative of the outer, plug in the inner as is. Then you start over and go to your second chain, and you do all 3 steps. The derivative of the outer, plug in the inner as is, and finally the last step, multiply everything by the derivative of the inner. Now you just have to simplify that big old mess. So you put the numbers out front. 4 times negative 1 times 7 gives you a negative 28. We still have the cosine of 7x to the third. And then we still have sine of 7x. So make sure you don't forget anything. The sine of 7x. So there is your final best credit, full credit, best answer. That's a double chain. Kind of fun, huh? Okay, number 9. Again, you see that funny trig notation. This 5/3 applies to everything immediately to the left and to the right of it. So rewrite it. Okay, the 24 is still out front, but it's the sine of 4x all to the 5/3. Then you can easily see what's going on. We have 3 functions. We have the sine, we have 4x, and we have something to the 5/3. So 3 functions, 2 chains right here. Okay, what is the outermost of everything? Right here, something to the 5/3. We are 5/3ing these 2 functions. This is the outermost function. So for our first chain, that 24 comes along for the ride, but our outer function is something to the 5/3. The inner as is always everything else. So the sine of 4x. Now, we know, since this is still a composite function, there has to be another chain. That's another way to catch it. So here, the outer function is sine, and the inner function is 4x. So those are our 2 chains. So now remember, for the first chain, you only do the first 2 steps. All right, so let's get started. So the derivative of the outer, 24 comes along for the ride. The derivative of something to the 5/3 is going to be 5/3 times something to the 2/3. All right, because if we kind of go off to the side here, 5/3 minus 1, and I'm going to write 1 as 3/3. That's how we get the 2/3. Okay, so now we plug in the inner as is. So we plug in the sine of 4x right here. Alrighty, so the sine of 4x. That is my first chain. After the first 2 steps, derivative of the outer, plug in the inner as is. Now you start over and you go to the second chain. And the second chain, you do all 3 steps of the chain rule. So we keep going. The derivative of the outer, the derivative of the sine, is cosine. Remember, blank set of parentheses. Second step, we plug in the inner as is, so that goes right there. 4x, and finally the last step, the derivative of the inner, the derivative of 4x is 4. All right, so there it is, double chain. To simplify this, we are going to, I'm going to put 24 over 1, and I'm going to multiply these 3 fractions. 24 over 1 times 5 over 3 times, I'm going to make 4 over 1 a fraction too. Okay, 24 times 5 times 4 gives me 480, and then 480 and divided by that 3 gives me 160. So when we multiply all those numbers in there, we get 160. We still have the sine of 4x, all to the 2/3, and we still have the cosine of 4x. There you have it. That is a big, messy derivative. Okay, ready for a triple chain? How do we know it's a triple chain? Well, you count the number of functions. We have the cosine, we have x squared plus 3, we have something to the 4th, right there, and we have something to the 100th. 4 functions. 4 functions. The number of chains is always 1 less. So 4 functions, that means we have 3 chains. This is a triple chain. The good thing about a triple chain in my class is that you never have to simplify. So let's figure out what is the outermost. The outermost of everything is that 100th. We are 100thing the cosine of x squared plus 3 to the 4th. So the outermost function is something to the 100th. The inner as is always everything else. So everything else is the cosine of x squared plus 3 to the 4th. Now, right here, what is the outermost of this thing? Well, we're taking the cosine of x squared plus 3 to the 4th. That 4 only applies to this, so we're cosining all of that. So the second chain, the cosine is the outer, and then the inner as is everything else. X squared plus 3 to the 4th. We still have a composite function here, 2 functions, so we know to go again. So what is the outermost here? Something to the 4th. We are 4thing x squared plus 3. So the outermost is something to the 4th, and the inner is x squared plus 3. And now we know we're done because this is no longer a composite function. So you just go to work. you only do the first two steps here. On the second chain, you only do the first two steps. When you have more than one chain, you only do the third step, all three steps on the last chain. Okay? So let's set it up. We start with our first chain. What is the derivative of something to the 100th? That is 100 times something to the 99th. And then the second step, we plug in the inner as is right here. So we plug in the cosine of x squared plus 3 all to the 4th. All right, first two steps. Derivative of the outer, inner as is. Now we start over and go to the second chain. What's the derivative of the outer? The derivative of cosine is negative sine, blank set of parentheses. And now inside that parentheses we plug in the inner as is, x squared plus 3 to the 4th. X squared plus 3 to the 4th. So we did the first two steps. Derivative of the outer, plug in the inner as is. Now we start over and we go to the third chain. What's the derivative of the outer? 4 times something to the third. Second step, we plug in the inner as is. X squared plus 3. And finally, on the last chain, we take the last step. What's the derivative of the inner? The derivative of x squared is 2x. And the derivative of 3 is 0. So there you have it. Let's walk through it again. First chain, derivative of the outer, 100 times something to the 99th, plug in the inner as is. Start over. Second chain, derivative of the outer, negative sine, plug in the inner as is, x squared plus 3 to the 4th. Start over. Third chain, derivative of the outer, 4 times something to the third, inner as is, and finally, don't forget, on the last chain, you take the derivative of the inner. And that is as far as you need to go. If you get that far, I am thrilled. You do not have to simplify ever on a triple chain. Okay, finally, number 11. This symbol right here, you guys, this means that we want to find the second derivative. That is the Leibniz notation for second derivative. In order to find the second derivative, we have to find the first derivative first. So we go to work. Our outer function is cosine. So 4 cosine is our outer function, and our inner function is 5x. Okay, so for the first derivative, f prime of x, the 4 comes along for the ride. The derivative of the outer is negative sine, blank set of parentheses. The inner as is 5x. And the derivative of the inner is 5. Now, before you can move on to the second derivative, you have to simplify first. All right, before going to the second derivative. All right, so if we simplify, that's huge. You got to simplify. So if we simplify this, our first derivative, let's see, f prime of x, we just multiply the 4, the negative 1, and the 5, and we get negative 20 sine of 5x. That's our first derivative. All right, so let's put that up here. Negative 20 sine of 5x. Now we're ready to just do it again. So we take the derivative of the first derivative to get to the second derivative. The outer function is sine, so don't forget negative 20 sine. The inner function is 5x. All right, so we just get going. F double prime, negative 20 comes along for the ride. The derivative of the outer, the derivative of the sine is cosine, blank set of parentheses. The inner as is 5x. And finally, the derivative of the inner is 5 times 5. And to simplify that, we just put the 20 times the 5 out front. So our second derivative is 100 cosine of 5x. All right, there you have it. Thanks, calculus.